All right, so welcome everyone. We are online now. Welcome to the most interactive math class online, where every child gets to participate by God's grace. Now, we are doing length of a arc, and we are doing area of a sector. All right, so we also did perimeter of that sector. We are looking at question 11 in the book, the math textbook. I don't have to call the name, Tulsi. Now, we're looking at question 11. Question 11 says, people follow me. It's there. Follow me. Oh, they asked to give the answer to three significant figures, somebody's saying. So it would have been 177. Thank you, Matthias.
So for the textbook, is it volume 1 or volume 2?
Yeah. All right, let's
Volume
go.
2.
Sorry?
For the textbook, is it volume 1 or volume 2?
You heard what you just said? I didn't hear. If you look at question 9, are you asking what to put the answer to? I'm not hearing you properly.
Sorry, sir. I said for the textbook, is it volume 1 or volume
Oh,
2?
this is volume 1. This is volume 1, chapter 4.
Okay, sir, no problem.
Yeah, cool. Cool. All right. Um, Question 11 says, what distance in centimeter does a wheel? So let's put our wheel, people. Let's put our wheel. This is my wheel. All right. And they gave us the radius. They gave us the radius. So this is my wheel, and the radius of the wheel, sorry. The radius of the wheel is 21 centimeters. Now remember, the radius is from the center, we could call it O, to any point on the circumference. Right, so what this distance in cm centimeter does a wheel of radius 21 cm travel in one complete revolution? So let's work that part first. So let's say this is the ground, all right? And the wheel is touching the ground here. And the wheel is going to make one complete revolution. So it's going to turn and turn and turn. One complete will stop right here. So it would have gone a distance somewhere to here on the ground. What would I use? Am I going to use area or am I going to use circumference? Anybody? First person to talk.
Circumference.
Circumference of a
Circumference.
circle, correct. Circumference,
Circumference.
correct. So circumference of a circle is 2 pi r. Oh, just now, people, hold on, my battery dying. Give me 2 seconds, please, to run and get the All right. Sorry. Right. Good. All right. So circumference is 2 pi r. But they told us, notice they told us to use pi as how much? Number 11.
22/7.
Correct. And the radius is 21. So that will give me 1 revolution. How much is that, people? Just pay answer in the chat, please. Pay answer in the chat. Isaiah, you're sending the answer to teacher. You're sending the answer to teacher privately, so only I would see answer. Start with your fraction first. So 22 divided by 7. And then you multiply by the other things. Right. So Stacia, you got knocked out. We're looking at question 11, which was the first part was easy. We had a circle and it's rolling on the ground. So it would have made a revolution. How much is that revolution? So it's 2 times pi times r. Just put your answers in the chat for me, please. I want to see if people are paying attention. So, no, I only want 1 revolution, Matthias. So how much what is the distance of 1 revolution? Tyrese, yes. Julia, yes. Shalomi, yes. Darius, yes. Johan Ser, no. Well, yeah. I don't know where you're using Johan Ser, but that's correct. It's a complete whole number. I don't know how you got a thing. Theodora, yes. You all, when you all purchase a good calculator now, and that's a calculator you'll use next year. Oh, and by the way, those persons who are doing exam in January, I want to meet with you all on Saturday night, 7 to 8. Is that possible? Tell me. Tell me now. Those people who are doing, so we doing past papers alone when we meet Saturday night. Just for an hour. Yes, Matthias, that's
Yes,
correct.
sir. That isn't a problem.
All right. Umesh, that's correct. Where is Marcus? Is Marcus here? Let me look for Marcus, boy. Janae, correct.
Yes, sir.
Marcus, me and see no answer from you. Yedaya, correct. Kyla, correct. Stacy Long, correct. Garcia, correct. Now, the class is not only for people who doing maths in January. If you want to jump in, it's not at any extra cost or anything. Right? So we're just going to start a past paper. I'll put it in the chat. If everybody want to come, it's okay. But we'll just go start at 7 and finish by 8:15, 8:30. We wouldn't go beyond an hour and a half, but we aiming for an hour. All right, Jada. Yeah, Jada, correct. All right, people. So that was straightforward. That part was straightforward. Marcus,
Sir,
I ain't
what would
seen
be
no
the,
answer from you. Eh?
what would be the unit for this answer?
Yeah, the units will be, you always put units. You always put units. Deshaun, thank you, correct. Jedidia, correct. You must put units. Now, Umesh was asking me what book I'm using, which is very good. People, if you don't practice, you will, sorry, you'll never get good at maths. You could come to how much math class and the teacher teaching all right, blah, blah, blah. Once you don't practice, you're in trouble. All right, let's move on. How many times will the circle turn when the bicycle travels a distance of 528 centimeters? So we know one revolution is equal to what? Which is 132 centimeters. That is one revolution. So they're asking how many revolutions in 528 centimeters. How much is that? Oh, that is why you had put that, Matthias. You had work out everything. Smart, smart. Yeah, smart. All right. Go to the other of the class. So Matthias worked that out earlier o'clock and I didn't work it. So I was like, what this man put in, boy? But he was ahead of me, you see. All right. So Julia, correct. Stacia, correct. Who else, boy? What Tyrese, boy? Yeah, Matthias, boy. Yeah, correct. Umesh? Yeah, Umesh, correct.
So I have one question too.
Yeah, Antonio.
So what do you mean by one complete revolution, sir?
One revolution means that the distance that the circle will move around. Let me erase all these things. That's not it. All right. Right, Antonio. Right. Let me see if I could paint this, your answer for you. Now, one revolution represents if this circle, if this is a ball or a circle, well, it's a circle. If it's moving, yeah, it will really be nice to animate this. You see this distance here? Oops. This distance here to the point where it began right there. That's one revolution. So that distance we worked out to be this. So on the ground, it would have moved. Let's say this is the same thing. So if we took a piece of thread, and let's say this is a bicycle wheel. Antonio, ride bike, boy?
Yes, sir.
Yeah. If this is a bicycle wheel, and you find the circumference of the bicycle wheel is, or you put a thread, and you get the length of the bicycle wheel, that's one revolution. One circle. So if you take that thread, which is the entire distance around the bicycle wheel, and you spread it out. So this is my thread here, right? This is one revolution again, because this is the distance of one going around this circle one time, once. Sorry. So the revolution would be the distance around the circle once. And we found out how much that is. So the circumference of the circle is exactly a revolution. Antonio, your circumference is a revolution. So we found our circumference C to be 132 centimeters. So on the ground, that is the distance the circle will travel. Okay? Hello?
Yes, sir.
So if the circle traveled, if one revolution is equal to traveling a distance of 132 centimeters, how much would 528 centimeters? How much revolutions is that? Here how I do it. You're multiplying this by this, cross multiply. So it's 528 multiplied by 1, which is the same thing. And you divide by what is left, which is the 132. And this will give you 4 revolutions. 132 by 4 is 528. So this is 4 revs. All right, people.
That's I understand, you know.
Yeah, cool. All right, so I want to look at, I'm recording, so I want to look at area of a sector. So I'm erasing this. It's online for you
So
to.
don't erase it off yet, so you know, ask for.
Oh, okay. But I'm recording, so you could always go back to YouTube and get the same thing.
Yes, sir.
All right. Let's just. So what I want to look at. Oops. Hold on. Right. Let's look at question 16. But before we look at question 16, I want you to write area of a sector. So this is a new word that I'm introducing, a sector. So we need to know what is a sector. Now, let's see. Now, everything, its genesis is in the circle. All right, so I'm trying a big one. Let's say my circle, there's a center here. From the center to any point on the circumference, what do we call that white line again, Deandra? From the center to any point on the circumference, Deandra. So let me put a O to represent that this is the center. Deandra, so from this point here to this point here, let's call this point A. All right, this point here on the circumference. So what's this line called, Deandra? Where's Deandra? Deandra, you hearing me? All right, so I can't wait on Deandra. So anybody tell me from 0 to A is called
The radius.
The radius.
the radius. Thanks.
Radius.
Thank you.
48 to 55 years in human years. 48 to 55 in human years.
All right, so I have two radii now. So from the circumference to another point. So this is my sector. So people, I could actually I could delete this, but I could delete here. All right. All right. So I still, what we call this shape again?
A sector, a
Right.
segment.
So this is our sector. Right. Now, we know how to find the area of a sector. But if let's call this B. Now, if I draw a line from A to B, anybody could tell me what two shapes I have? Or one of the shape, call tell me what are the shapes? I have two shapes now. What are the
So
shapes?
so one will be a triangle, and I believe the next one will be like a arc.
Right? The one with the arc, you know what we call that?
A semicircle.
Semicircle.
All right. Well, yeah. We call it a segment. So we have this sector. Don't forget your sector, people. So we have three shapes. A sector. That's one. Oh boy, now is not a good time to get knocked off. And we learned already how to find the area of this sector. So we're good with that. But we need to find the area of a triangle given, well, this is a radius. This is a radius. I want to ask a question. A triangle with two sides equal. We call that triangle again?
An isosceles triangle.
Yes,
Isosceles.
an isosceles triangle. Look what we do. We formed an isosceles triangle. Now, we need to find this part here. And this part here is what we call the segment of the circle. So this is the segment of the circle. This is what we want to find. And we only have 10 minutes to do it because it's almost 6 o'clock. Even though I give people 5 minutes grace to come in class. All right, so y'all might have to give me 5 minutes grace. So this is this segment. This is a segment, and we want to find the area of this segment. But remember, I'm doing all this so that your mind will be seeing this segment, the triangle, and the sector. All right, so we're going now, people. Now, if they ask you to find the area of the segment, if they ask you to find the area of the segment, the area of the segment, that small piece at the top that we just showed you. Good evening, Jeremiah. To find this area of the segment, we need to find the area of the sector minus area of triangle. Good evening. Hello? That wasn't so hard. Right? So the yellow part at the top, which is called the segment, to find the area of the segment, we have to find the area of the sector minus the area of the triangle. Anybody lost? Well, look, I'll be lost yet. I ain't do nothing yet. All right?
Yes, sir.
All right. All right, write that down already?
Yes, sir.
All right. Well, we already know how to find the area of a sector. It will be pi r squared by theta over 360. But we never learned how to find area of a triangle that does not have a perpendicular like this. So in form 1, 2, and 3, they told you that area of a triangle so It's equal to what? Let me see if I remember. Area of a triangle is equal to what? I'm not man.
Base,
All right. Huh?
it's base by
So
height
height
by
by
base.
All right. Well, I hearing it. A half multiplied by the base multiplied by the height. But the height is the perpendicular height. What is the height called?
The perpendicular height.
The perpendicular height. There's another one that we have to learn. I will teach you that on Wednesday when you have all three sides of the triangle. Right? So we're doing that on Wednesday. Since we're doing this, I better teach you that one time. But there is the area of a triangle that we do when once we know an angle, people. Hello? There's an area of a triangle when we know an angle. That's what this one we have to find. So stick with me. Stick with me. This is very straightforward, very easy. All right. So I am saying there are three areas of triangle. One, a half base by height. And then there's one, and the height is the perpendicular height. The next area of a triangle that you know is when you know the three sides. I will teach you that on Wednesday, coming down to the end of class. But there's a third area of a triangle that sometimes people miss. You're supposed to know it for CXC. Well, you're supposed to know all three, actually, for CXC. But for this topic, the area of the triangle is once you know an angle, people. An angle. So that is what I want to teach you now. Area of a triangle given an angle. Area of triangle given an angle. Now, this is an easy formula. The formula is A is equal to a half A times B times the sine of C. Now, that looking like Greek, but it's not hard. Now, A and B are your radii.
So I have a question, sir.
Yeah, what is your question?
So is sine C the critical angle?
Sine C is the angle given. We call it the inclusive angle. Sine C represents the angle between the radii. Angle C, forget the sign for now. Angle C represents the angle between the radii. Angle between radii. All right. So A and B represents the two sides, side R and R. And angle C represents the angle. So let's call O C. That is angle C here. So write that down. Well, I'm recording the class, so you all would go it over. I have A times B. The dot in maths means multiply. The dot in math means multiply. All right, so you all learn something again. That's why I'm recording. It's 2 minutes past 6. Give me a little 2 minutes. Or the homework will be on this. So I write in area of a triangle is a half times A times B times sine C. Let's write this clearly. SINEC. All right. So I'm doing question. So please don't go anywhere yet. I'm doing question 16. I'm doing question 16. So notice part A, they asked me to find the area of the circle. Then they asked me to find the area of the sector, which is pi r squared by theta on 360. Let's use pi as 22 over 7. Oh, just now. What happened? This didn't come out. Question 16, the radius is ready. It's 3 point. Oh, lost. The radius is 3.5. Don't go. I seen a lot of people getting knocked off. Right. So the radius is 3.5 squared times theta, which is 120 over 360, minus, now this new part, it's a half times A, the radius, which is 3.5, by B, which is also 3.5, times sine, short is SIN, 120. Can somebody work that out? Let me see if I'll get the correct answer. And that's it for today. Let me work that out for me, please. Tell me what you got. Tell me what you get for the area of sector first. So I would write it down. Give me an answer to 2 decimal places. Anybody got on anything? What you got for the area sector? Anybody? My mic off or on? Anybody got
So
any?
I place my answer on the chat.
Oh, okay. Right. So 12.83 is correct. 12.83 is correct. I didn't realize you were putting it in the chat already. 12.83 is correct. What you all got for area of triangle? Area of triangle. Anybody? Theodora? Anybody? What you all got for area of triangle? Jada? Kylon? Kylon, what you all got for area of triangle? Y'all could just say it, because I'm just finishing up here. Umesh, that's correct.
So I get 5.30.
Yeah, that's correct. So subtract 12 point. Good. So let's write that. So area of triangle, write this down, Antonio, 12.83 minus 5.30.
So 7.53 cm cube.
Very good. 7.53. Centimeter squared. 7.53 centimeters squared. And that's it, people. So now we just have to learn area of sector, and this will end this topic in a way. Now, what CXC like to ask, CXP expect that you would have done this in Form 4. All right, but we doing it now, so that is all right. That is all right. We catch it already. You just need some practice. So I will give you a few questions on this for homework. So look out for the homework in the chat. And so on Wednesday, I'm going to do the 3 or 4 questions because you need to practice this, people. And then we have to do some areas, area of different shapes now, right? So, and then we have to do volume. We're moving on to volume of a cuboid. CXC love to ask volume of cubes and volume of cylinders. And then when we finish with that, we may go on to some matrices. That's section 2. And then I want to go to functions and relations. But remember, people, on Saturday night, we have a class from 7 to 8. Oh no. Well, I say it's 7 to 8:15. I have to go out on Saturday because I'm a Seventh-day Adventist. And so if I'm late, I will send a message to the chat. I doubt I should meet home by 7. All right, so 7 to 8. If anybody else want to join, if everybody here want to join, you're free to join. There's no extra cost or anything. So you could always join the chat.
That's it.
So I think just now, hold on.